Math 100, Lesson 10-4. We're going to add, subtract, and divide radical expressions. Now, in order to add and subtract our radical expressions, just like when we have any other kind of algebraic expression, we can only add and subtract if they are like terms. So these must be like terms if we're going to add and subtract them. Now, what I mean by like terms is like you can add x plus 2x because they have the same variable. You can add 3y plus 5y because they have the same variable. So when we think of radicals, we need to think of them as being sort of like our variables. So we've got 7 on the square root of 2 plus 8 on the square root of 2. So square root of 2 is the like term. So we are able to add the 7 plus the 8, and I would get 15 on the square root of 2. I add the coefficient that is sitting in front of the square root of x. So if I had 9 on the cube root of 7 plus 12 on the cube root of 7 minus 6x on the cube root of 7. Okay, well, they all have the cube root of 7. Well, that's good news. So I'm going to try to add their coefficients. But when you look at the coefficients this time, we have 9, 12, and 6x. Well, 6x is not like 9 and 12. So I'm not going to be able to add the 6x. So I'm only going to add this 9 and 12 to give me 21 on the cube root of 7. I'll bring down this minus 6x on the cube root of 7. All right. Now, my math lab is going to want you to go one step farther. There's nothing else technically I can do here. I cannot actually subtract these. But what I can do is factor out that cube root of 7. Factor out the common factor. And so I'd be left with 21 minus 6x. So my math lab is going to want you to do that. Just heads up there. All right, 7 on the 4th root of 3x minus 2 on the 4th root of 3x plus 2 on the cube root of 3x. All right, so we're going to add to and subtract anything that's like terms. Now, what I need you to notice here is that this root is a cube root. It's different. So you cannot call that one a like term. The only like terms we have are these first two. So 7 minus 2 gives me 5 on the 4th root of 3x, and I will bring down this plus 2 on the cube root of 3x. And there is no factoring out here because the 4th root of 3x and the cube root of 3x are entirely different. So that one is finished just like it is. Okay, so this time I don't appear to have any like terms, but we are not finished because I can simplify these first. Okay, so we're going to simplify first, and then we're going to try to add. Okay, so the square root of 20, I think of it like 4 times 5. The square root of 45, I think of it as 9 times 5. The reason I want to do that, I can take the square root of 4. It is 2. So I end up with 3 times 2 times the square root of 5 plus, this 5 stays here, the square root of 9 is 3 and then I still have that square root of 5. All right, so I go ahead and multiply that 3 times 2. I get 6 on the square root of 5, plus the 5 times 3 is 15 on the square root of 5. Now I do have like terms. They both have a square root of 5, so I can add their coefficients, and I get 21 on the square root of 5. You're not looking for decimal answers. All right? Okay, so 3 on the square root of 12x minus 6 on the square root of 27x. Again, these are not like terms, right? Because we have the 12x and the 27x. So I'm going to simplify first again. Okay, this would be 4 times 3x. 27, I would think of that as 9 times 3x. Now the square root of 4 I can do, and when I do that, I pull it out and multiply it by the 3 that is sitting there. So I end up with 6 on the square root of 3x minus the square root of 9 is 3. When I pull it out, it multiplies by the 6 that is sitting there. So I get 18 on the square root of 3x. Now I have like terms. I can do 6 minus 18 gives me negative 12 on the square root of 3x. All right. Gonna take some practice. All right, 8 on the square root of 5 minus 6 on the square root of 2. All right, definitely not like terms. So I want to simplify, but neither one of these will simplify. So they can't simplify. There are no like terms. So this particular problem cannot be simplified. There's nothing I can do to it. It's as simplified as it's going to get. All right, so let's try 3 on the cube root of 24. Minus 5 on the cube root of 81. All right, not like terms. They both are cube roots, but it's 2 different numbers under there. So we need to simplify first. I need to simplify 24 into 2 numbers that I can take the cube root of one of them. Well, I'm going to use 8 times 3. Think the same way about 81, something you can take the square root, the cube root of. 9 won't work. You can't take the cube root of 9. Okay, so I'm going to use 27 times 3. I can take the cube root of 27. All right, so I'll write this out this time. The cube root of 8 is 2, and I still have this cube root of 3 sitting inside. The cube root of 27 is 3, and I still have this cube root of 3 sitting inside. So when I pull those numbers out, I multiply. I don't always show this 3 times 2 sitting here. I just wanted to show you one more time. So I end up with 6 on the cube root of 3 minus 15 on the cube root of 3. Don't forget your root. Now they are like terms, and I can subtract, and I get negative 9 on the cube root of 3. That would be my answer. All right, let's put some variables in there. Okay, so 5 on the cube root of x squared y plus the cube root of 27 x to the 5th y to the 4th. All right, definitely not like terms, so I need to simplify first. Well, this first one, you cannot simplify that at all. I can't take the cube root of x squared or of y, no matter what I do. Okay, I'm going to try to separate this one into numbers that I can take the cube root of. Okay, I know I can take the cube root of 27. I just did it up above. Well, over there to the left. All right, so I'm going to leave that at 27. When you take 5 divided by 3, that is not a whole number. So I'm going to change that to an x cubed, which means I'm going to have an x squared over here. All right. And then 4 divided by 3 is also not a whole number. So I'm going to use y cubed, which means I'm going to have a y over here. Because it still has to say x to the 5th, y to the 4th. All right. Just bringing this one down, didn't change it. Now, the cube root of 27 is 3. The cube root of x cubed is x. And the cube root of y cubed is y. I still have cube root of x squared y. Now I have like terms. Right? They both have the cube root of x squared y. But this 5 and this 3xy, I can't add those together. So they really aren't like terms. This is one of those where my math lab is going to want you to factor out the common factor. They both do have that cube root of x squared y. And then we would be left with 5 plus 3xy. Okay, let's go do some division now. So that's adding and subtracting. Let's do some dividing. So there's a rule for our division here, and you can write this rule either direction. If I have the nth root of a fraction, I can change it to the nth root of a divided by the nth root of b. In other words, you take the root of the numerator and the denominator. All right, so if I have the cube root of 8 over 125, then that means the cube root of 8 over the cube root of 125. Well, you can do both of those. Cube root of 8 is 2. Cube root of 125 is 5. So my answer would be 2/5. Let's stick some variables in here. All right, square root of this fraction. So I'm going to separate it like the little rule says that I can. All right. Now in the denominator, I can take the square root of y to the 10th and I get y to the 5th because 10 divided by 2 is 5. Okay, so that's great. In my numerator, I can take the square root of 9x squared, but then there will be this other x sitting there. Because it's got to be 9x cubed. The square root of 9 is 3. The square root of x squared is x. And I still have this x sitting inside. And my y to the 5th is in the denominator. So that would be my solution. Okay, I'm going to write this one a little differently. This one's already going to be split up. Okay, so this time I already have it written as the square root of the numerator divided by the square root of the denominator. But when I look at that, I can actually divide those numbers. So I'm going to go backwards this time. I'm going to say, I'm going to stick them both up under the one radical. Because I can simplify that. The square root of, all right, 40 divided by 2 is 20. X to the 5th divided by x is x to the 4th. So I just simplified what was inside. Simplified the inside, and that's how I got 20x to the fourth. Now I'm going to take the square root. Okay. That means I've got to break up that 20. No, where am I? So I've got 4x to the fourth, because I can take the square root of x to the fourth, but you can't just say it's not a 20. 4 times 5 is 20. So now I take the square root of 4, I get 2. The square root of x to the fourth, I get x squared. And this square root of 5 stays inside. I can't do anything with it. So that would be my solution. All right, I've got 2 more that I want to show you. We'll be done with this. Okay, so my math lab is going to do this, and this is a little bit tricky because in the denominator that 2 is sitting on the outside. So the first thing I'm going to do is rewrite what this says, because really this says 1/2 times the square root of 50xy divided by the square root of 2. So let that sink in for a minute. That 2 that was sitting out front of the square root of 2, it's like I slid it over to the left. But you can't have a nothing in the numerator, and multiplying 1 times the square root of 50xy doesn't change that square root of 50xy. Okay, so this little 1/2 is going to stay out front. And now I am going to put this under 1 radical, because I recognize I can simplify 50 divided by 2. So that little 1/2 stays there. And I know that 50 divided by 2 is 25, and I still have that xy. Okay, so I got this little 1/2. I can take the square root of 25, but I cannot take the square root of x or y. The square root of 25 is 5, and then I still have that x and y sitting inside. So there's 2 ways you could write this answer. Now we're going to go ahead and multiply 1/2 times 5, and that gives me 5 over 2 times the square root of xy. So that's one way you could write that answer. Okay, the fraction times the square root. Or I could think about it like this, and I could say 5 on the square root of on the square root of xy divided by 2. And my math lab would take either answer there. Now, if you're going to write it as this answer, then you can't put the 1 down there, because that would not be simplified. So my math lab will take either this answer or it will take this answer. They're the same. All right. So that is all I've got for you for section 4. Let me know if you've got any questions.